Good morning, students. Myself, Vijay Shankar from ECE Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in the third unit of electrostatics. In the last class, we started the examples in the electrostatics. We did the 5 examples. Let us see the next example. A charge is distributed. Here, a charge is distributed on x-axis of a Cartesian system having a line charge density. Line charge density means rho L. Rho L is equal to 3x square microcoulomb per meter. Find the total charge over the length of 10 meters. Find the total charge over the length of the 10 meters. Okay. The differential length be dl is equal to dx. Why it is dl is equal to dx? The charge is distributed on the x-axis of the Cartesian coordinate system. So dl is equal to the dx in x direction, and corresponding charge is dq is equal to rho L into dl. We know the formula for the dq is equal to rho L into dl, dq is equal to rho s into ds, dq is equal to rho v into dv also. Okay, my dear friends. So the q is equal to, what is the q now? The integral, the line integral L rho L into dl. What is the rho L given? 3x square. This is a micro is there. You can keep that in the final. 3x square. The dl is now, it is in the x direction, the dx. Q is equal to integral 0 to 10, 3x square into dx. The integral of 3x square is a 3x cube by 3. The limitations is for the total charge over the length of the 10 meters. Means it starts from the 0 to 10. Lower limit is a 0, upper limit is a 10. Okay. So 3 get cancelled here. X cube means 10 cube minus the 0. The x is a 0 now. Sorry. So x value is a 10. So 10 cube minus 0. So 10 cube means it's 1,000. Already we have in this given line charge density micro is there, the 10 power minus 6. Otherwise it's a 10 power 3 into 10 power minus 6 means it is a 10 power minus 3 coulombs. That is nothing but 1 millicoulombs. Got it, my students? And next example. Here, a volume charge density is given. The previous example, they given the line charge density. Now we can give it as a rho v as 10z square x sine pi y. Find the total charge inside the volume. X, the variable is varies from -1 to the 2. Y is from 0 to 1, and 3 is z is a 3 to 3.6. And the rho v is given the 10z square x sine pi y, the coulomb per meter cube. Rho v means the coulomb per meter cube. Rho s is a coulomb per meter square, and rho L is a coulomb per meter. We know the differential volume is the product of the Cartesian coordinate system dx, dy, and the dz. Got it, my students? And the relation between the charge, the rho v into dv, q is equal to integral volume integral rho v into dv, and rho v is given as 10z square x sine pi y, and the dv is nothing but the dx, dy, dz. So with respect to the x, one integral, and with respect to the y, another integral we can apply, and with respect to the z, we can use another integral, and varies from x is varies from -1 to the 2. 10 is a common, x into dx, and another integral, the y, varies from the 0 to 1, sine pi y into dy, with another integral, the z, the limitations is 3 to 3.6 z square dz. Okay, my dear friends. So that is equal to 10 multiplying with the x is a x square by 2, with the lower limit is a -1, upper limit is a 2, and sine integral is a minus cos minus pi y by y, pi also there, because the y coefficient is a pi, from 0 to 1, and z square is a z cube by 3, with upper limit is a 3.6, lower limit is a 3. So simplify the equation here. So 10 into x square by 2, that is a 2 square minus -1 whole square by 2 as of the x limitations, minus cos pi, y value is a 1, minus already we have here, minus of cos pi into 0 by the pi. Okay, and this is only the multiplication factor, my dear friends. And again the multiply z 3.6 whole cube minus 3 whole cube by 3. Okay, simplify the function. Cos pi value, that is equal to q is equal to 10 into 4 minus 1, 3 by 2, and keep the minus here, and multiply here. The cos pi is a -1, cos 0 is 1 by the pi, and 3.6 whole cube minus 3 whole cube is 27 by 3. That is equal to, is the 2 5s 10, and 5 3s are 15. 15 into, multiply this minus here, the -2 there, plus 2 by pi, 3 pi is there, and it is a 3.6 whole cube minus 27, and again it is a 3 5s, and 5 2s are 10, 10 by pi, 3.6 whole cube. You can find the value. Then you get the total value is a 62.57. 62.57 value, my students. Got it? The next example, a uniform line charge, infinite in extent with the rho L is equal to, a uniform line charge infinite in extended with the rho L is equal to 20 nanocoulomb per meter, lies along the z-axis find the E bar at the point 683 meters. A uniform line charge infinite in extended. So what is the electric field intensity when there is a infinite line charge distributed on the z-axis here? Is rho L by the 2 pi epsilon naught r into AR bar. So formula we have a uniform line charge infinite in extent. The rho L is equal to 20 nanocoulomb per meters, lies along the z-axis. And you have to find that E bar at the point 683 meters. 6 is the x-axis and 8 and 3. So what is R now? R is equal to, because of a rho L, the differential length is on the z-axis, means one point is the 0, 0, 0, z. Then you can find the R bar, the distance. Suppose here the point is this one and differential length 683. To find the electric field density here is E bar. Add a small differential length dl bar here. Nothing but is a rho L is there. R bar is equal to 6 minus 0 into x bar, because it is a x is a 0, y is a 0, and z. A point on the z-axis means you'll get only the z value. 6 minus 0 into x bar, 8 minus 0 into ay bar, and the z-axis here, as a line is on the along the z-axis, E bar cannot have any component along the z direction. So z component is eliminated. So do not consider the z coordinate with calculating the R. So this value is a 0 into az, eliminating the z bar component. Okay. And AR bar is the vector value, the 6 to x bar plus 8 ay bar under root of 6 square plus 8 square. You get the 10. And 6 square is 36 and 64 under root of 100. 100 is a 10 value. 6 by 10 is a 0.6 and 8 by 10 is a 0.8. Then you can substitute E bar is equal to rho L. What is a rho L given? 20 nano, 20 into the power of minus 19, 2 into pi. Epsilon naught is 8.854 into the power of minus 12. And R is here the 10 value. So actually the R square, to find the electric field intensity, the normal point charge. What is it? The infinite line charge. The value is R1. The R is a 10. And AR bar 0.6 into x bar plus 0.8 into ay bar. Simplify this function. You'll get the coefficient of ax and the coefficient of ay. Okay, my students. The next example. So prove that the electric field intensity at a point P located at a distance R from an infinite line charge with uniform charge density rho L coulomb per meter is E bar is equal to rho L by the 2 pi epsilon naught R into R. Using the expression, the infinite line charge E bar is equal to. Let us see here, they are asking that prove the electric field intensity a point P located on y-axis at a distance of R from the R-axis. So what is the point here? The 0. A point on the x-axis or y-axis means x is a 0, y is the distance R, and z is a 0. And here the point is a 0, 0, z, because a point on the z-axis, there is no any x and y. We need to find the electric field intensity at the point P. That too, it's a rho L by the 2 pi epsilon naught of R. Proof. Take AR bar is equal to 0 minus 0. There is no any x component. 0 minus 0 into ax bar plus r minus 0 into ay bar plus 0 minus z az bar. So actually in the infinite line chart, we are eliminating the z component. We have only the r into ay bar. So in the denominator, this is ar bar is equal to, this is only the r bar, my friends. Ar bar is equal to r bar by the magnitude of r bar. Is ax bar is a 0 and r into ay bar minus z into az bar by under root of r square plus z square. Got it? So actually, to find the electric field intensity at the point P means, take this apart and there is a part here. To start from here itself to meet at the point P, there is a downward direction of z into minus az bar. Okay, and with the distance here, the r into ay bar. Okay, ay bar is a positive direction. So r into ay bar minus z into az bar under root of r square plus z square. Okay. Now at the point charge, the differential electric field intensity dE bar is equal to dq by 4 pi epsilon naught r square into ar bar. That is equal to dq by, what is a dq? Because we are assuming a differential length on the z axis, dl is equal to dz. Okay, dl is equal to differential length is nothing but the dz along the z axis, and dq is equal to rho l into dl. Rho l into dl. That dl is on the z axis, so we are assuming that is a dl is equal to dz. Okay, 4 pi epsilon naught and r square is under root of r square plus z square whole square, and ar bar r into ay bar minus z into az bar whole divided by under root of r square plus z square. Okay. And now we need to find the dE bar is equal to dq. What is the dq? Substitute that as a rho l into dl, not the dl, dz by 4 pi epsilon naught. In the denominator, you can see here the square and the root is get cancelled, and here the r power 1 by 2 and this r square plus z square. Totally we get r square plus z square whole power 3 by 2 into multiply with r into ay bar, and we are eliminating the z component here because uniformly distributed on the z axis and symmetrically, and here also there is a differential length you can assume, so both are get cancelled. So we are eliminating the z component r into ay bar. And now let us assume here the theta z opposite side is a z and adjacent side is a r. Tan theta is equal. Tan theta is equal to, I assume here it is a tan theta. Tan theta is equal to r by z. Okay. Z by r only. The theta is the same. Here, whatever I assume, the theta is here, means opposite side is a z. Adjacent side is a r. So z is equal to r tan theta. and dz is equal to r into tan theta, nothing but is a secant square theta d theta. Got it, my students? Now I can substitute here the rho L into dz means r secant square theta d theta whole divided by 4 pi epsilon naught 4 pi epsilon naught r square plus z square. Now can substitute r square plus, and z is nothing but r square tan square theta whole power 3 by 2. Hence I am substituting the z is equal to r tan theta, z square is r square tan square theta whole power 3 by 2 into r, because it is in the ay direction. Okay, let us take ay first of all, r into ay. And now here check the r square is a common. R square whole power 3 by 2 means r cube rho L r secant square theta whole divided by 4 pi epsilon naught, and here it is a r square, you can common, get it, that value is a r cube. R square whole power 3 by 2 is r cube, and 1 plus tan square theta is a secant square theta. Secant square theta whole power 3 by 2 means secant cube theta. Secant cube theta into r ay bar. Okay. Now here the d theta is also there, d theta. Now r and r is r square. Get cancel of r cube here. Secant square and the cube is get cancelled. Now it's a rho L by 4 pi r epsilon naught r is a constant, and 1 by secant theta is a cos theta. Cos theta into d theta. Ay bar is also there. Now I can apply the integral. It is a differential electric field intensity. Means apply the integral here. The theta value, the theta is varies because previously it is minus infinite to infinite as a z-axis. When the z is equal to, the value is z is equal to minus infinite. When z is equal to minus infinite, tan theta is equal to z by minus infinite by the r. Theta is equal to tan inverse infinite, that is nothing but minus pi by 2. And z is equal to plus infinite, theta is equal to pi by 2. So we'll take the minus pi by 2 the pi by 2. Minus pi by 2 the pi by 2. What is the cos theta integral value? Is a sin theta. Sin theta is pi by 2 minus pi by 2. Okay, I'm applying only the integral. What is the sin pi by 2? 1 minus sin of minus theta is a minus sin theta. Again, sin pi by 2 is a 1. We get the value of total value is a 2. So E bar is equal to, now the E bar is equal to rho L by the 2 pi, not the 2 pi, sorry, rho L. Here it is a 4 is a 4 pi epsilon naught r into ay bar. This total integral, whatever we have, it is, we got the 2 value, 2 into 2. So 2's total value is a rho L ay bar whole divided by the 2 pi epsilon naught r. That ay can write as ar because it is in the y direction. With the distance of origin to the point P is r, means let take this also the ar. So E bar is equal to, we got rho L ar bar by the 2 pi epsilon naught r. Got it, my students? This is one of the infinite line charge on the z-axis. To prove the E bar is equal to rho L by the 2 pi epsilon naught to ER. Got it, my students? See, in a cylindrical coordinate system, the distance vector have two components as shown in the figure. The component is along the negative z-axis is minus z a z bar, and towards positive direction of r into AR bar. Actually, it is a radial component. We can write the AY bar also. Nothing is a change. And in the E bar, it can be noted that due to the symmetry of Z component will cancel in E bar. But let us prove that is the mathematical also. If it is a substituting that value in the AZ bar is also there, that becomes is a 0. The theta is equal to 1 by r secant theta is there, nothing but cos theta. And similarly here also the sin theta by cos theta is a tan theta, and 1 by secant theta is a cos theta. Cos theta get cancelled. Sin theta is nothing but cos theta. Integral of sin theta is a cos theta. We can substitute the limits of plus pi by 2 to the minus pi by 2. Cos pi by 2 is a 0. So second term becomes a 0. This here, the second term becomes a 0. Even if you can keep that Z component and continue the process mathematically, the second term becomes a 0. The first term one is a 1 minus of minus 1 is a 2. Rho L by the 2 pi epsilon naught r into AR. Got it, my dear students? Understand? Mathematical also, the Z component is get cancelled. Hence, looking at the symmetry and cancelling in the terms makes the mathematical exercises much more easy. The next example you can see. That is a uniform line charge. A uniform line charge. Rho L is equal to 25 nanocoulomb meter lies on a line x is equal to minus 3 meters. See here, minus 3 meters is our opposite side of the x-axis. X is a positive direction towards here, and because the x is a minus 3 meters means the opposite side. 3 meters here, and 4 meters in a free space is a 4 meters. Find the electric field intensity at the point 235 to 315 meters. Okay, as shown in the figure here, the line x is equal to minus 3 constant and y is equal to 4 is a constant, is a line parallel to the z of 6, and z can take in any value. The E bar at the point P is 2, 3, 15 is to be calculated here. See, we already proved that the value, the E bar is equal to, for the uniform line charge distributed on the z-axis, E bar is equal to rho L by the 2 pi epsilon naught r into AR bar. To find the R bar component, the minus 3, 4 is given. Then let us take the Z, and Z component is need not we can take because it is uniformly distributed on the z-axis. We are eliminating the Z. So R bar is equal to, so 2 minus of minus 3 is a 5, and 3 minus 4 is a minus 1 AY bar, and we are not taking that is a Z component. The line is parallel to Z axis. E bar cannot have any component of AZ bar direction. So AR bar is equal to 5AX bar minus AY bar under root of 25 plus 1 is a 26. Substituting the E bar, rho L by the 2 pi epsilon naught R. R is under root of 26. AR bar is a 5 A by X bar minus. Simplify this one, we'll get AX bar coefficient 86.42 and AY bar coefficient is a minus 28 minus 17.284 AY bar volts per meter. The electric field intensity is measured in the volts per meter. Got it, my students? The next one, The charge lies in y is equal to 5 meters plane. The charge lies in y is equal to 5 meters plane in the form of an infinite square sheet. See here, a 5 meters plane. Okay. The charge lies y is equal to minus 5 meters plane in the form of infinite square sheet with uniform charge density rho s is equal to 20 nano coulomb per meter square. Determine the E bar at all the points. The plane y is equal to 5 meters constant is parallel to the xz plane as shown in the figure here. XZ plane means this is a XZ plane. So actually it looks like this. Okay, this is a plane of XZ is exactly it's a parallel. The plane of y is equal to 5 minus 5 meters constant is parallel to the XZ plane. Got it, what is then you can find the E bar is equal to rho s by the 2 epsilon is a formula for the infinite sheet of charge. This is a E bar is equal to rho s by 2 epsilon. And it is in the AY direction. A and bar is in general. So y is greater than the minus 5. The E bar component will along the plus A bar as normal direction to the plane. So you take that A and bar is equal to AY bar. So rho s is given. What is the rho s given? 20 nano coulomb per meter square. 20 into nano is a 10 power minus 9. And 2 into epsilon naught is 8.854 into the power of minus 12. Substitute that, you'll get the E bar is equal to 1129.43 AY bar volt per meter. If it is in the negative direction along the minus AY bar direction with the same magnitude, AY is in the minus AY bar. So y is less than the minus 5. Considering the y is greater than the minus 5, we got it is a positive value. If it is a less than the minus 5 means we get the negative value. At any point to the left or the right of the plane, magnitude of E bar is a constant and acts as a normal to the plane. That is, when you can take the magnitude is both the conditions, electric field intensity for the given rho is 20 nano coulomb per meter square is 1129.43. Go ahead, my students. And the next example you can see here. Find the E bar at a point P is 152 meters in a free space. If the point charge is 6 microcoulomb is located at 001, the uniform line charge density is given along the x-axis, and uniform sheet of charge is also given. Rho s is equal to, for the plane, z is equal to minus 1. So we have a point charge means electric field intensity. The formula is E bar is equal to Q by 4 pi epsilon naught R square into AR bar. Got it, my students? And after finding that, the differential electric field intensity is a dq by 4 pi epsilon naught R square AR bar. What is the dq now? When they are asking that the uniform charge density rho L is given, dq is equal to rho L into d. And another, it is also the rho s is given, the dq is equal to rho s into d. Substitute the dq as a rho L here in the first case. And second, it is a rho L is equal to 180 nanocoulombs. And in the third, it is a rho s is equal to, the first case is a point charge. Q is equal to 6 microcoulombs. Before that, you can find the R bar. R bar means the P and the A is a receiving end is a P and sending end is a A. So 1 minus 0 into AX bar, 5 minus 0 AY bar, and 2 minus 1 into AZ bar. And if the coefficients of AX, AY, and AZ, the square is nothing but the magnitude under root of 27. So E bar is equal to, at the point charge, 6 into 10 power of minus 4. You can substitute this using this expression here. 4 pi epsilon naught into R square under root of 27 whole square. Okay, this is the R value, magnitude. And in the AR bar also you get the root 27. Nothing but the 27 whole power 3 by 2. Understood? So you'll get simplify the function and get write the AX bar coefficient, AY bar coefficient, and AZ bar coefficient also. You'll get the electric field intensity at the point charge. Now, you can find by substituting a line rho L is given. If it is an infinite, hence the standard is a rho L by the 2 pi epsilon naught R into R. What is a R? They are saying that uniform line charge rho L 180 nanocoulombs along the x-axis. Along the x-axis means x having x value is a 0 and the remaining the 2 points is a 0, 0. X is value and y and the z is a 0. But as line is along the x-axis, no component of E bar along the AX bar. So 5 minus 0 and the 2 minus 0. So 5 minus 0 into AY bar and 2 minus 0 into AZ bar. Since the rho L is along the x-axis, there is no any component. Previously, we said that uniformly charge is distributed on the z-axis, means we are not taking the z component. Similarly, here also, the charge is distributed and that rho L is given. It is along the x-axis. X component is eliminated. Substitute here the 2 pi epsilon naught under root of 29. Here we are not placing the whole square because it is not the r square distance. It is a small r, infinite line charge. So under root of 29 and the AR bar also having under root of 29. Simplify, you get only AY bar coefficient and the AZ bar coefficient. We are not having the X bar coefficient since the charge is distributed on the x-axis, along the x-axis. Similarly, the rho S is over a plane of Z is equal to minus 1, means what is a E bar is equal to rho S by the 2 pi epsilon naught. Rho S by 2 epsilon naught AZ bar. Rho S is given and epsilon naught also we know. You can find the value of E bar is equal to in terms of rho S here. Rho S by the 2 epsilon AN bar. AN bar is AZ. Okay. See, third case, surface charge density over a plane Z is equal to minus 1. The plane is parallel to the XY plane. This is a XY plane, my This is a parallel to that of the same sheet is parallel to the of XZ plane. Normal to the direction of AN bar towards the AZ bar direction. It's a positive direction. Okay, above the Z is equal to minus 1 plane, they are saying that. Here the 0 is the Z and there is the next one value is a minus 1. The plane is above the Z, means towards the positive direction. So AN bar is equal to, we can take it as AZ. Okay, so all the three cases for the point charge, line charge, and the surface charge, the total electric field intensity E bar is equal to the first E1 bar having AX and AY, and AZ also, and E2 bar there is no any X component because the charge is distributed along the x-axis, AY and the AZ, and E3 bar is a surface charge density. It is on parallel to that of the XY plane, and Z is equal to minus 1 plane. Above the Z is equal to minus 1 plane, having all the Z component. So add all the AX components, AY components, and AZ components. Finally, you get E bar is equal to the total electric field intensity for the point, line, and the surface charge density. Okay, my dear students. Next example here, the charge lies on a circular disk. R is less than or equal to 4 meters. Z is equal to 0 with the density rho s, charge density, surface charge density. Rho s is equal to 10 power minus 4 by R coulomb per meter square. Determine the E bar at R is equal to 0. Z is equal to 3 meters. Okay, this is a circle we have. The circle means what is the differential charge? dq is equal to actually the rho s into ds. The rho s into ds is a cylindrical coordinate system. We can observe the ds z bar is equal to. So there is no any component of z, having only the r dr into d phi. There is no any z component. The differential surface area normal to the z direction. Okay, the dq is equal to rho s into ds is a dr r into d phi. Got it, my dear friends? Consider the differential surface area carrying the charge dq, the normal direction to the ds z bar, hence ds z bar. I already told differential surface area normal to the z direction. There is no any z component, dz component. We have only the r component and the phi component. The phi is not alone with the right. With the radius, we can write the r into d phi. Okay, what is it? It is a dq is equal to rho s. What is the rho s? 10 power minus 1 by r and r into dr d phi. R get cancelled. dq is equal to 10 power minus 1 dr into d phi. The differential surface area, differential electric field intensity E bar is equal to dq by 4 pi epsilon naught r square into r. Okay, this is a point charge equation. Understood? So components along the r bar minus r bar and r bar. The component in the z is equal to 3. Along az bar is a 3 into z bar. So by using these two components, minus r into r bar and 3 into az bar, and here we are eliminating the r components. Okay, in the previously a uniform charge is distributed on the z axis, means the z component is eliminated. Now in this r component is eliminated. There is no any r component, only we are taking the z component. 10 power minus 4 dr and d phi, the 4 pi epsilon naught r square plus 9, 4 power 3 by 2. So we are not taking that r into r bar. It can be seen that due to the symmetry about the z axis, all the real terms will cancel each other, as there will not have any component of E bar along the R bar. Okay. And simplify the expression here, the integral value, the dr and d phi, dr is varies from the 0 to 4 only, because they given r is equal to 4, the radius of 4. So 0 to 4, and the phi varies from the 0 to 2 pi, 360 degrees. Okay, so dr and the d phi. And by using there is no any r and the dr in the numerator, we use r as a 3 tan theta, dr is equal to, using the right angle triangle here, a right angle triangle, then we can use that as r is equal to tan theta is equal to r by 3. Tan theta is equal to r by 3. R is the opposite side and the 3 is the adjacent side. So substitute the change of values, r values as the theta values. So theta is varies from 0 to theta to 0 degrees. Simplify the function, then we'll get E bar is equal to 1.5059 AZ bar. Okay, 1.5059. Got it, my students?